if we go back to this graph and we graph the size of the change, so we graph A to B, B to C, C to D, we get this. And what this says is, at the bottom of that graph, as we added workers, we got more, but then we started getting less from each worker. So as we hired that third, fourth, and fifth worker, we got progressively less. D to E, E to F. We got progressively less from each worker. Okay? That, right? B to C is bigger than C to D, D to E, E to F. So these points start going downward because those points are the difference between C to D, D to E, and E to F. So each one gets smaller, and the curve, in this case, goes down. This is the marginal product of labor. Okay? So now I can look at this, and I can decide how many workers are the right number of workers for me to hire. Okay? I can also do that average. Remember I did that average? 1 worker produces 5, 2 workers produce 10, right? 3 workers produce 40, whatever it is. I can figure out what the average is. And I can draw the marginal product, and I can draw the average product of A and B and C and D and E and F. The average changes more slowly than the marginal. The average goes where the marginal goes, but more slowly. So when the marginal is rising, the average rises with it. When the marginal falls, the average goes down with it. Okay? But more slowly. The average follows the marginal. Okay, so let's do a simple example of this to make sure we understand. Let's say that we have a business and in walks our cowboy friend. He's the only one there. Ignore the other 2 for now. That line I just drew, since he's the only person in the room, that line is the marginal height, right? The person coming in, the last person, the next person, that's the marginal. But since he's the only person there, that's also the average. So that's the marginal and the average. Now the punk rock dude comes in. That's the average, right? That's the average. Sorry. See, I screwed this thing up. You let me screw this thing up. That's the marginal. He's the marginal person, right? Where's the average? Well, the average is in between. So this was both the marginal and the average. Now the marginal goes way down, but the average doesn't fall as fast. Okay? Now in comes the college professor, and there's the marginal. So the marginal's gone down again, all the way down to here. Where's the average now? Well, maybe the average is in here somewhere. The average went down, but more slowly than the marginal went down. So the average always moves with the marginal toward the marginal, okay? But more slowly. When the professor's kid comes in, now the marginal's all the way down here because the kid's really short. And again, it's going to pull that average down, but maybe the average is there. Okay? So the marginal leads the way, the average follows it. The marginal is in red, the average stuff is in blue, right? Average is blue, marginal is red. Each person who comes in is the new marginal. And as each shorter marginal comes in, the average goes down, follows the marginal, but more slowly than the average went. Is that good? we get that? It's one of those things you got to think about. The marginal is what's setting the direction and this change. The average is following the marginal around. Okay? All right. So tied to all this, we have the law of diminishing returns. And we've already sort of said it, but this is what it says more precisely. As a firm uses more of a variable input with a given quantity of fixed inputs, the marginal product of the variable input eventually diminishes. Again, you have your restaurant. It has the same size no matter what. You go to your favorite place to get your hair done. There's a certain number of chairs in there. They don't add extra chairs. They don't have extra sinks and extra chairs that they can just roll out. They've got 6 sinks and 6 chairs, and that's it. If you have 5 stylists, you can add a 6th one and get more productivity. Once you have 6 people working, if you bring in a 7th, what does the 7th person do? Well, fill in on break, maybe? That 7th person is not going to be very effective as a worker because they don't have their own chair and their own, right? If you have a company and they're out digging holes and you've got 5 shovels, workers 1, 2, 3, 4, 5, we can see what they do. Worker 6, what does worker 6 get to do if there's no shovel? Okay? Even with 5 workers, that 4th and 5th worker might get in the way of the other workers a little bit, and so 5 of them together might not be as productive as 2 or 3 of them, right? The average productivity of those workers might be lower when there's 5 of them than there is when there's 3 of them. But that 6th worker, that 6th guy, doesn't have a shovel. That 6th worker is just going to have diminishing productivity, diminishing returns. They're not going to be that productive. Okay. Productivity creates costs. Productive workers, really productive workers, produce products at a lower cost than not so productive workers. The pin maker in the factory where all those guys are producing 40,000 pins a day, they're way more productive than the pin maker by themselves who is making 4 pins a day. Productivity matches with cost. The more productive we are, the less cost. A professor who can teach 100 students is going to have a lower cost per student than a professor can only teach 4 students. Put me in a classroom with 1,000 students. At UCLA, they teach principles of economics to 2,000 people at a time. Giant auditorium. That professor is productive. Think of the income they're producing. That one professor has 2,000 students, where one of their colleagues might have 2 students. So we can match their cost to their productivity. All right? Simple example here. You have a worker that makes 100 pencils a day. That worker's paid $50 a day. What's that mean? Well, 100 pencils for $50 is 2 pencils for every dollar that I spend. So I get 2 pencils per dollar. Or another way, there's 50 cents of labor cost in the pencil. If I know what that pencil sells for and I know how productive the workers are that make it, I can figure out what the labor cost per pencil is. Okay? My productivity, if I figure out a new way to make pencils, and now this worker makes 1,000 pencils a day, and I still pay them $50. Now the pencils cost 5 cents of labor apiece, not 50 cents of labor apiece. If I increase my productivity from 100 pencils a day to 1,000 pencils a day, I lower the cost from 50 cents a pencil to 5 cents a pencil. All right? Productivity creates costs for us. All right? The more burritos we make per worker, the lower the cost of the burrito, and the more the worker is worth to the business. If you want to get your boss to give you a raise, the easiest way to do that, or economically speaking, the easiest way to do that is to say, look, I'm more productive than these other people, therefore I should get paid more. Marginal product will move inversely to the marginal cost. So again, when I got more productive making pencils, the cost went down. So my productivity went up. The cost of making the pencil went down. As I get more productive, the cost of the things I make go down. It's inverse, right? One goes up, one goes down. Inverse. So we can graph the marginal product. We already did that. We can graph the marginal cost. Do you notice something about these graphs? What you should, because basically if I take that marginal product curve and I flip it upside down, it looks exactly like the marginal cost curve. Marginal product creates marginal cost. Right? The more productive I get, the lower my cost. As my marginal productivity is going down on the right side of the marginal product graph, right? This is going down. My productivity is not as high. My cost is going up. The marginal product and marginal cost are just opposite of each other. They're inverses. Okay? Exciting? Yeah. That marginal cost curve is also the supply curve. It's the supply curve. So productivity of the workers has a lot to do with the supply of the good. And the productivity, the marginal productivity and the marginal cost, the supply, are inverses of each other. Everything's related in the great circle of life. All right. So I have what we call fixed and variable inputs. We're talking here about something that economists call the short run. If I have fixed and variable inputs, I'm in the short run. A fixed input is an input that doesn't change regardless of the quantity. The store, this is not Harry Potter, right? The store that I have to use, my place that my restaurant is, my building, or the place I have in a strip mall or something, my physical space, doesn't change as my number of customers changes. It stays the same. It's a fixed cost because how much my rent is not affected by the quantity of people who come in and buy my stuff. So Chipotle is paying rent on their building. The person who rented them that space doesn't care that they didn't sell anything today. Right? They still want their rent. Then we have variable inputs. Variable inputs are the things that vary by the quantity. So I can change the amount of labor that I have. I can change, if I'm making burritos, I have 1 tortilla per burrito. Right? That changes with the quantity of burritos that I sell. The amount of beans, the amount of chicken, the amount of barbacoa, the amount of cheese, the amount of hot sauce, the amount of guacamole, all change as I sell more or less. Those are variable inputs. Okay? Fixed inputs create fixed costs, and variable inputs create variable costs. And hopefully that's logical, right? Marginal costs are the additional costs of producing one more. So I have fixed cost, I have variable cost, I have marginal cost. Marginal cost is the cost of producing more. All right? The sum of all my costs is called total cost. Is that exciting? It's called total cost. And we'll write this out. Then I can also calculate my average cost, my per unit cost. And I do that by dividing my other costs by the quantity. So if I take my total cost and divide it by my quantity, that's my average total cost. If I take my fixed cost and divide it by quantity, that's my average fixed cost. If I take my variable cost and divide it by the quantity, that's my average variable cost. Right? Lovely. So, equations, and I just sort of said that. You're going to see the letters. It's like Sesame Street, yes? I don't know if you ever watched Sesame Street when you were little. But today's class is brought to you by the letters C, T, A, F, V, and M. C is for cost, T is for total, A is for average, F is for fixed, V is for variable, and M is for marginal. So my total cost is the sum of my total fixed cost and my total variable cost. My average total cost is my average fixed cost plus my average variable cost. And all those things are the three things above them, all divided by Q, by the quantity. So TC over Q is ATC, TFC over Q is AFC, TVC over Q is AVC. Okay? The marginal cost is the change in my total variable cost, not my fixed cost. So why not? Because fixed cost doesn't change. That's kind of the definition of fixed cost, right? Fixed cost does not change. So my marginal cost, which is the change, the addition from adding one more, comes completely from my variable cost. So the marginal cost is the change. Remember, delta is a letter that means Greek letter, and we use it to mean change. So the marginal cost is the change in my variable cost. Yes.